Okay guys, today we're going to look at scientific notation. I want you to solve these top 4 questions using whatever strategy you want to, but no calculator. So see what you can do with these 4 using any strategy. You can show work on paper. If you know a trick or a pattern, you can do that too. So go ahead and pause the video and see if you can come up with those 4 answers. Okay guys, check your answers. Did you get all 4 of them right? So it didn't matter which strategy you used to get them, but there are some tricks and patterns when we're dealing with multiplying by a power of 10. Notice all of these are powers of 10 like we've been learning the last couple days. They're all powers of 10s. So now we're going to talk about this notation called scientific notation, and it's just another way to write a number. So you've learned a lot of them in elementary school: standard form, expanded form, word form. Scientific notation is just another form. So I want you to look down this list and see if you can find similarities and differences between all of these on this list. So there's something that all of these have that all of these don't have. And there's 3 big important ones. So let me see, I'm going to give you some time to see if you can come up with these 3 big differences that all of these have, but all of those don't have that same thing. Go ahead and pause the video and see if you can come up with those on your own. Okay guys, so the first one might have been easiest to find. That's that they all have multiplication. So all of my ones over here have multiplication and not all of the ones over here do. The second one was that all of these have a power of 10. They're all being multiplied by a power of 10. These are not all being multiplied by a power of 10. The third one was probably the hardest, that each of these numbers, the first number there, is a number that is greater than or equal to 1, but it's always less than 10. So it never is bigger than 9.999. See, this one has 6,300. So that's the first 3 rules of what puts a number in scientific notation. You have to have multiplication, a power of 10, and the first number always has to be greater than or equal to 1 and less than 10. So now you're going to circle yes if you think these are in scientific notation, or no if the number is not in scientific notation, and tell me why over here. I'm going to give you some time to figure out your answer. I believe there are 4 no's as a little hint. See what you can do there. Okay guys, how'd you do? These are the answers. This is our first no because it's not a number between 1 and 10. Our second no is number 5 because it doesn't have a power of 10. Then number 6 because it's not multiplication. And number 8 because it's also not a number between 1 and 10. You have to have a 1 or greater in that 1's place to be considered a number greater than or equal to 1 and less than 10. All right, let's go to the back. Do some practicing. So scientific notation is a way to express very large numbers, like how many stars are in our solar system, or very small numbers, like the weight of a grain of sand. So notice that this is written in scientific notation, and this one is written in standard form. Okay, so those 3 parts must be multiplication, must be a power of 10, and then our last one must be a number between 1 and 10. Go ahead and make up any example you want here. Okay, so we're going to place a decimal point after the first non-zero digit. Count the decimal places the decimal point has moved and write that number as the exponent of 10. If the original number is more than 10, you're going to use a positive exponent. If the original number is less than 1, you're going to use a negative exponent. So let's see what that looks like. So this is moving 5 spaces to the right. We're multiplying by 10 5 times. We are multiplying by 10 5 times. And that's going to make this go 5 place values bigger. Positive exponent for the larger numbers. This decimal place, now we're multiplying by 1/10 5 times. Remember that 10 to the negative 5th power is 1/10. And that's going to make our decimal move to the left 5 spaces. So when it's a negative exponent, we are making our number smaller and moving to the left. All right, let's do some practice. Go ahead and turn to the next page. And let's convert these examples. So we're going to go from scientific notation to standard form because I think it's easier to do that one first, okay? So this is 10 to the 6th power. It's a positive 6, which means we're making this number bigger. Rewrite your number and move your decimal 6 place values to the right because that's how much bigger this number is getting. Fill in all those place values with zeros and rewrite your number so it doesn't have all those loopies underneath. And then go back and put your commas in. 1, 2, 3, comma. 1, 2, 3, comma. Scientific notation, standard form. Let's try this one. Now we're moving 4 places to the right. Notice I'm not adding 4 zeros. You can't, because those 2 have taken up 2 of those places. 1, 2, 3, 4. So we're only adding 2 zeros to the end of this, if you want to look at it that way. So rewrite your number without loopies, so it looks nice and neat, like mine, and then count for your comma. Let's try one more. 2 more. This one is a negative 6, which means we're multiplying by 1/10. And when you multiply by a fraction or decimal, your number gets smaller. Fill in with place values again. Rewrite your number without any loopies. Make sure your decimal is in the right place. I moved it here. 1, 2, 3, 4, 5 zeros. And then a 6 and a 1. Scientific notation, standard form. This one is a negative 4, so I'm moving left 4 spaces because my number is getting smaller. Rewrite your number without any loops so that we can read your answer. And there you go. Try these down at the bottom, and I'll show you the answers. Go ahead and pause your video. Guys, how'd you do? 240 million, so this one only has 7 zeros. 150.6. It only moves 2 places to the right. This one moves 6 places to the right. 8,030,000. This one moves 8 places to the left, so you're going to have 7 zeros after the decimal before the 2 and 4. This one goes 2 places to the left, so 0.01506, and this one moves 6 places left, so you're going to have 1, 2, 3, 4, 5 zeros before the 803. Now let's try going the other way. So we're going to give it to you in standard form, and you need to turn it into scientific notation. So remember, it has to be in this form. And right now, this first number needs to be written so that there's a decimal there between the 4 and 5. one number before the decimal, and it can't be a 0. Then my power of 10 needs to be how many places I would move to get back to this original number. So if I'm here in scientific notation, I move 2 places to the right. Let's try it again. My decimal needs to be there for it to be in scientific notation. And I would move 1, 2, 3, 4 places to the right to get this number back to my original 59,000. All right, let's look at the negatives. So now I need my decimal here. Still, always need one number in front of the decimal. That's not a 0. But how many places do I move back? 1, 2, 3 to get it back to my original number. And because I'm going left, that's a -3. So I'm going to move this number 3 places left to get back to my original. Same thing here. 5.9 times 10. And how many times do I have to move left? 1, 2, 3, 4, 5 to get this number back to my original number. All right, you try the bottom and then check your answers after you pause the video. Okay, guys, how'd you do? So this one is 3.05 times 10 to the 3rd power, 3.407 times 10 to the 4th power, 9 times 10 to the 5th power, and if you put 9.0, that's fine, but remember scientific notation, we're trying to write as few numbers as possible, so we don't need that 0 there, but if you put it, it's okay. 6.07 times 10 to the 6th, we definitely don't need to write all those zeros after this. 3.05 times 10 to the -3rd power, because I'm going left from here to get back to my original number in standard form. And then 7 times 10 to the -1st power. This one was harder, but my decimal needs to be there for it to be in scientific notation, so it has to move back 1 to get to this original number. Remember, like, this is kind of like a math problem, so you can't, whatever this number is, when you multiply it by 10 6 times, it needs to get back to this number that's in standard form. It can't be a different number. Here's our last two. 9, again, if you put 9.0, that's fine, times 10 to the -6th power, moves back 6 places from there, and 6.7 times 10 to the -6th power. We're going to compare in the next class. So you can save those last couple of ones. Hope this helped, guys.